And we also have the addition of new volume of water due to the melting of land-grounded ice. So that's why Greenland and Antarctica are so of interest currently in the research community, because it's land-grounded ice. They hold significant volumes of water, and how much water they add, how quickly, is of significant interest right now. And of course, those two processes are the root of global eustatic sea level projections. These are the projections that we see most frequently talked about in the national news, published by, the IPCC global sea level rise projections are widely talked about generally in the national news. The figure is from the 2012 National Academies report on West Coast sea level rise. I'm going to talk about that a little bit later. But essentially, those two processes generate these global eustatic sea level projections. But once you start to sort of look in detail at the global distribution of observed eustatic sea level, it's really complex. So we have this really nice, clear global average sea level rise curve of 3 millimeters per year over the last 40 years or so. But when you distribute it, when you look at the spatial distribution, it's a much more complex picture that emerges. And that's shown in the upper right. This is from the University of Colorado Sea Level Group. And essentially shows the spatial distribution of the rate of sea level rise over about the last 40 years. And one of the interesting things about this map is that it suggests that in the Pacific Northwest, at least, we've had little, if any, sea level rise trend in the satellite era. So in contrast to the global pattern of a significant rising rate of sea level, in the Pacific Northwest, there's little indication that we've had anything that looks similar to that trend. A lot of variability. So at the lower left,